Example 11. The cost of producing X products is given by C of X equals 1,316,876 plus 1.5x plus 44x squared. Find the value of x that minimizes the average cost function if x is between 1 and 255. So we're looking at only units from 1 to 255 and whatever critical number we find, if any. Now, average cost is C bar of x is cost divided by x. So our C bar of x is 1,316,876 divided by x plus 1.5x divided by x plus 44x squared divided by x. So that is written in a format that I can take the derivative of easily. That's going to be 1,316,876x to the negative 1 plus 1.5 plus 44x. So C bar prime is going to be negative 1,316,876x to the negative 2 plus 0 plus 44. Now we set that equal to 0. And I'm going to go ahead and write it with a positive exponent. Plus 44 is 0. So negative 1,316,876 over x squared is negative 44. I'm going to multiply by x squared. And I get negative 1,316,876 is negative 44x squared. Divide by negative 44. And I get 173 equals, no, that's not right, I'm sorry. Hold on. I get 229 or something like that. Let me check. Negative 131,6,876 divided by 44 is 29,929 is x squared. So x is 173 when you take the square root of that. Now, it's technically negative 173 and positive 173 because x square equations have two answers, but we only want the one that's between 1 and 255, which is 173. So I'm going to check just to be sure. Look, it needs to be a minimum, which means it should be falling here and rising here. We already know it's 0 right there, but we want to know if it's negative followed by positive. So I'm going to do C bar prime of 5, because that's on the left of 173. And then I'll do C bar prime of 200. The first one should be negative, the second one should be positive. So 1,316,876 divided by 5 let's make sure. That's not right. I'm doing C bar. So this is the function that I'm evaluating. So it's negative 1,316,876 divided by 5 squared plus 0 plus 44. And that does come out to be a negative number. And then I have to do negative 1,316,876 divided by 200 squared plus 44. And that should be a positive number. Let's see. Negative 1316876 divided by 200 squared plus 44 is about 11.0781. So it is falling here. You have a negative first derivative, a 0, and then a positive. So that's your local minimum. Now, it will be your absolute minimum if it is smaller than those two. So we need to do average cost. Now remember what the average cost function is. It's 1316876 divided by x plus 1.5 plus 44x, not the derivative. This time I'm looking at the actual average cost function. And I need to check the endpoints. So C bar of 1, C bar of 173, and C bar of 255. And that has to be, the smallest one needs to be the 173. So 1316876 divided by 1 plus 1.5 plus 44 times 1 is 1316921.5. Then 1316876 divided by 173 plus 1.5 plus 44 is 7657.5, and 1316876. Let's see. Wait a minute. Let me double check that. Okay. 1316876 divided by 173 plus 1.5 plus 44 times 173. Okay, because there's an X right here that I missed that time, so you've got to be careful. I'm just putting it in the calculator. Okay, so it's 15225.5. So it's still bigger than, it's still smaller than that million that's up there. So here I have 1316876 divided by 255 plus 1.5 plus 44 times 255. And that's 16,385.72. So this is the smallest of the three. So that is for 173 products. Now, they don't ask us what the minimum average cost is. That's what it is, this number we found. But we had to check to make sure it was the smallest of the endpoints and the critical number. So 173 products is our answer.